Hey guys, sorry for the mess. I'm going to show you this electric setup I'm working on and pretty much finished with the electric side. Got a 240 volt outlet over here for the dryer. That comes into a 50 amp ground fault breaker, which will protect me from ground faults if you end up with power going in to ground. It'll just kill the power so don't get hurt. It's important because the kettle's grounded and the liquid therefore touching the kettle. If any power, any leak, or any kind of malfunction causes this to be electrically live, we're going to kill power to everything, so I don't touch this and electrocute myself. We then got the power running out of that and around here into the control box. We're going to turn power onto the control box. Over here we've got a switch to the element. This PID is sensing the temperature via this temperature sensor. That wire comes out there and around and in here, and it's in the kettle right now. There's an element underneath the basket and it's telling me this water's heated up to 131. We're shooting for 152, which would be your average mash temperature. I had it preheated a little bit. We've also got an alarm set on here, which is going to go off around 148. So it's going to tell me, give me a warning if I'm out of the room right when we're about to hit our mash temperature. I'm going to flip the switch, which just allows the alarm to go off. Once it goes off, I'll go ahead and turn that off. Right now what the PID is doing is it's only giving intermittent power to that element. But as things continue, as it realizes, oh, I maybe need to give it a little bit more power to get going, it's going to start bumping that temperature up, that power headed to the element. It's going to be on for longer instead of just these short pulses. And then once it gets real close to this 152 we want to hit, it's going to realize, hey, we're getting close, we need to slow down so we don't get too hot. This will be aided in, once I get the whole thing set up, by a pump. I've got a March pump which will be hooked up to this, which will recirculate water coming out of the kettle into the pump all the way back in the top to make sure there's an even temperature all around and it's all mixed. And then this will control a fan. I have the fan over here, which will be hooked up to some ducts and out the dryer vent, which is in the corner over there. You can see that works. And we'll see how this goes. But we've got our switch here on. Our alarm is going to go off, I think, at around 146 or so. So that'll let me know if I left the room. I'm heading for this strike temperature. When I get close, it's going to know, and it's going to give me this alarm so I can come in and say, okay, I'm just about ready. I can go ahead and dump in my grain. I can stop measuring hops or doing whatever I'm doing. It's time to get the mash started. Got about 5 or 6 gallons in here. Obviously it's going to heat slower with more water and grain in there, and it'll compensate by keeping the element on more often, giving it more power. We're getting close to that alarm value. There it is. You just kill power to the alarm, even though you see here the alarm is still going off, and I could reset that. What I'm going to do next is hold this button down for about 5 seconds. We're going to go into manual mode, which is going to put us into 37% power. What I'm going to do though is just bump that power up. See how fast we can get this thing started. So now we got it going towards a boil. And we'll see how fast the temperature moves at just 100% power. This is always on manual control. This is what we'll use during the boil, except we'll turn it down to get a proper boil off rate so it doesn't boil too fast at 100% power. Alright. Oh, look, the alarm's going off. We're almost at a boil. As you can see here, I might need to calibrate. Ooh, fogged up. I need to calibrate that temperature probe before I actually use it. And we're starting to come to a boil already, and I almost wonder if I took this, how hard we'd see it boil if I took that off. The idea here, so once the boil starts, we can come down in our manual mode and back her off a significant bit. Yeah, let's bring her up to 50% power maybe. What that's going to do here in manual mode, you'll notice the alarm's still on, but I killed the power here. Had the pump off, fan off, but once I get it hooked up over there to the dryer vent, that's going to go on when we boil. Let's bump her up a little more. But depending on what size batch you're doing, you may need more or less power. Especially this is a 5500 watt element. You don't need all of that power to just keep a good rolling boil. It helps to give it the full juice to get it boiling, but once you're getting there, I'll go ahead and take the temperature probe out. Once you're getting there, you can start cutting it back and control the boil off rate that way. I'm going to go ahead and use a towel because it's a little bit hot. And this is what's going to help me pull the grain out. You can see the element in there. You can see it's getting a pretty nice boil as is. Starting to boil just off that element. And again, it's that boil temperature. It's getting right about to the whole thing boiling. Those natural convections will allow us not to use the pump, except we'll flip the pump on toward the end of the boil in order to sanitize our chiller and everything for pumping after the boil. But we'll be able to cut our temperature back, cut our boil back once it really gets going, and whatever we need to maintain a rolling boil is what we'll use.